cool. So that was a lot of neuroscience, and that's very cool. So how do we actually study these? These are like very, very hard stuff to study. And so what we're interested is back to the big question of thinking as how do we do in virtual experiment, and then how do we use the LC system as a gear or a gadget that sort of mediates effect and project to all cortical regions, right? And can we establish a causal relationship between activations and maybe the internal representation of, let's say, fearful conditions? So let's propose something. Let's say that if we activate the LCNE system computationally, maybe we can trigger a behavior of rumination, let's say, even with the unpresentness of distal stimulus. That means without giving a stimulus of fear, can it still ruminate? This is where we develop towards a computational model. And the idea is we have a sort of a neural network, and actually a family of neural networks. We have this gadgets, this LCNE system, and is inspired by neural Turing machine. And we have neuroscience data, right? This data is particularly for giving different arousal conditions, the pupillary reflex, which signifies the pretty much how much the subject is fearing, sort of, triggers the sympathetic nervous system. And then we have a data-driven controller, which is the LCNE system, using mechanistic insights. And how do we turn actual neuroscience idea is using math, which for the sake of time, we're not going to, but this is the basic idea. And we had some preliminary result, which this is a fit of the model to the data. And then the last slide is pretty interesting, is where this is sort of the activations of these neurons using a mathematical tool called principal component analysis. And we see the NE. This looks very familiar to me when I first saw this. Yay, this is the inverted U shape that we see earlier, which we haven't investigated into how this correlates yet, but it's just something we found pretty interesting. And so why the hustle? I want to conclude with pretty much a bigger idea of using things in computation tools to model some mechanistic insights in neuroscience. Maybe we can do these gadgets, and then we can actually simulate these conditions of fear and see what these mechanistic insights of LCNE actually do. And this is us. I'm mainly in charge of all the code, math stuff, and V in charge of a lot of neuroscience, psychology, ethics studies, research, and Ivy with some data processing as well, literature reviews, and Jesse with mainly neuroscience and psychology stuff as well. And here's our reference. Thank you.
Okay, that's pretty cool. Yeah, you guys did a really good job of sort of framing it within a computational frame that's also behavioral, explore, exploit. Mapping of the neuroscience to the modeling, I thought, is a hard thing to do, and I feel like you pulled it off, actually. And then I like the psychological descriptions of you, et cetera, and it's exciting that you have a little preliminary finding even with this PCA, so it'll be fun to see where this goes. I like it because it's different, too, so it's cool.
Thank you.
Very nice. Questions? Comments?